Now, example 24, we have already done almost exactly as example number 12. So, I am not repeating this example number 24 here. I'll talk about this very interesting question now, that is example number 25, and it is also an IIT question. Now, looking at this question, you will be comfortable in understanding that how smoothly the basic concept can be able to serve you in solving the problem of any level. Question number 25 says, two square metallic plates of 1 meter side are kept 0.1 meter apart like a parallel plate capacitor in air in such a way. So, here the situation is that there are two square shaped metallic plates. There are two square shaped metallic plates of each side 1 meter, and they are not kept very far apart. Instead, the separation, although the size of these plates is 1 meter each, but they are kept just 1 centimeter apart or 0.01 meter apart, and they are kept not in air completely. Instead, they are kept partly in oil. They are kept in a way that these plates are partly in oil and partly in air. And they are connected, these two capacitor plates, they are connected to a 500 volt of EMF, battery of EMF 500 volt. And then these plates, these two square plates are actually moved down with some velocity into this oil, where this oil has a dielectric constant. This oil itself has a dielectric constant of 11. So, the situation is that these two parallel plates, which are 1 centimeter apart, each of area 1 meter square, are slowly lowered into this oil. Question is, how much current will flow? How much current will be drawn from this battery in the process? So, I know one thing, that is, current is dq by dt. So, if I am interested in, during the lowering of these plates, how much current will be drawn from the battery, I need to first get charge, instantaneous charge on the plates of this battery. And to get instantaneous charge on the plates of this battery, we assume an intermediate situation that while lowering at a particular time, say y height of these plates in water or in that insulating oil, and how much of this, how much height will be in air? 1 minus y. So, the status is that during the lowering of these plates into this insulating oil, say at a moment y height of it in insulating oil and 1 minus y height of it in air. So, question is, in that situation when we have the plates in this state, what is the equivalent capacitance of this arrangement? So, if in this situation, if I go for an equivalent capacitance, I can say the capacitance of first part, in air, the air part of these capacitor plates, it will become epsilon naught area area stands for 1 into 1 minus y, because one side is 1 meter, but this side which is in air is 1 minus y divided by d. So this is the capacitance of this air part. Similarly, let's look for capacitance of C2 for oil part. For oil part, it will be K epsilon naught, because it is the oil which is filled in the gap between the plates into 1 into y by d, because this side is 1, this side is y, so its area will be 1 into y. So here you have the two capacitors basically, and these two capacitors they are in parallel. Positive of these two capacitors will be joined to each other and negative of these two capacitors will be joined to each other. So if this is one part is C1, lower part is C2, the positive of C1 and positive of C2 are actually connected to each other. So they are in parallel. So if I say what will be the C equivalent, you will say C1 plus C2. So C equivalent at any intermediate stage during lowering would be epsilon naught by d into 1 minus y plus ky. So C equivalent would be epsilon naught by d into 1 plus y into k minus 1. This is giving you the equivalent capacitance at any intermediate stage. And then, what will be the charge? The charge that will exist on the plates, we said let's get instantaneous charge. So instantaneous charge will be C equivalent into V. So instantaneous charge will be epsilon naught V by d into 1 plus y into k minus 1. This is instantaneous charge on the plates of capacitor. But the question is, now we are close to the question. In the question we are asked, what current will be drawn? What current will be drawn if these plates are being lowered at a speed of 0.001 meter per second? So if these plates are lowered at a speed of 0.001 meter per second, then what is the current that will be drawn from the battery? So I can say current is equal to dq by dt. So let's differentiate this. This will be epsilon naught v by d 1 0 plus k minus 1 into dy by dt, and the current will be epsilon naught v. V is what? 500 by gap is 0.01, k is 11 minus 1, and dy by dt is 0.001 meter per second. So we will finally get this current, which comes out to be 4.425 into 10 to the power minus 9 ampere. So it was a good question, and it was just about, putting your mind a bit more than direct solving the question on the basis of the formula. So question number 25 you have done, and it's an IIT question. And the next question is question number 26. It is again a question where the narrative of the question you have to see, and then as you move with patience, as per the details are given, you will be able to get the final solution. This is also an IIT question where question says there are two parallel plate capacitor A and B having same separation. So basically there are two parallel plate capacitor. First is capacitor A. This is capacitor A, and it has area which is mentioned here as 0.04 meter square. You have another capacitor, which is capacitor B. Although the separation between the plates in both of them is same, and that is having a value 8.85. We are keeping this value into 10 to the power minus 4 meter, so that with epsilon naught we can cancel this value. 8.85 into 10 to the power minus 4 meter. The area of plate B, area of this one, I can say area A2 is actually 0.02 meter square. So, area of capacitor, this is capacitor B and this is capacitor A. The two capacitors have got same separation between their plates, but area of capacitor A is double as that of area of capacitor B. Now question says, a slab of dielectric constant K is equal to 9, which has such dimensions that it can exactly fill the space between the plates of capacitor B, is placed inside A. So just imagine that there is a slab of dielectric which has just the same area as that of plate B. It means half. If it is filled in the capacitor A, it will have same dimension as that of B, it will just fill half of it. And it has a dielectric constant, how much? 9. So what will be the capacitance of it? And this whole capacitor plate A is actually joined to 110 volt of EMF. Part A says calculate the capacitance and energy stored in it. So first I am interested in the capacitance. So you know it is like two capacitors in parallel. Capacitor 1 will have area, will have value epsilon naught A by 2 by D. Epsilon naught A1 A by 2 by D, and capacitor 2 will have a value K epsilon naught A by 2 by D. So the equivalent capacitance here will be C1 plus C2. So epsilon naught by D into area by 2 will be 0.02. This is 0.02, 0.02. 0.02 plus K is 9 into 0.02. So C equivalent would be 8.854 or into 10 to the power minus 12 divided by 8.85 into 10 to the power minus 4 into, this is 0.2. This get cancelled. So C equivalent in the first case has a value 0.2 into 10 to the power minus 8 or 2 into 10 to the power minus 9 farad. So in this first situation, the equivalent capacitance is 2 into 10 to the power minus 9 farad and it is connected to a 110 volt source. So I get equivalent capacitance, I want energy also. Energy, it will be half into C equivalent into V square. So energy in this situation would be half into 2 into 10 to the power minus 9 and V square will be 110 square. So energy comes out to be 1.21 10 to the power minus 5 joule. Also, how much will be the charge? How much will be the charge? So charge will be Q is equal to C equivalent into V. C equivalent is 2 into 10 to the power minus 9. Potential is 110 volt. So you will have a charge 220 micro into 10 to the power minus 9 coulomb. So we have obtained for plate for capacitor A, which was half filled with this dielectric of constant 9, all these C equivalent, energy equivalent as well as the charge. So part A is done. B part, the battery is disconnected. Now looking at part B, the battery is disconnected and then the dielectric slab is also removed from A. What work done will be done by the external agency to remove the slab from A? So the situation is, so now we take part B. In part B, it is mentioned that the first capacitor where we have all this charge, initial energy and C equivalent, to this first capacitor, first the battery is detached. So first the battery is detached. This is capacitor A, which is already charged. But to this capacitor A, first the battery is detached and then this dielectric is removed from it. Now, what work is done in removing this dielectric? So first thing I would like to know what will be the new charge. So one thing you can say Q dash will be Q, because there is no way charge can go or come from. So Q dash will remain the same, that is 220 into 10 to the power minus 9 coulomb. Charge will remain intact, but its capacity will change. It will be epsilon naught A by D now. So its capacity will be 8.85 10 to the power minus 12 divided by 8.85 10 to the power minus 4 into 0.04. So its capacitance will be finally 4 into 10 to the power minus 10 farad. So there the equivalent capacitance was 2 into 10 to the power minus 9 farad. Here the equivalent capacitance is 4 into 10 to the power minus 10 farad. Charge is this. What will be the final energy? We can say Q dash square by 2C dash. So 220 into 10 to the power minus 9 square divided by 2 into 4 into 10 to the power minus 10. So as a whole, the final energy which will exist on this is 6.05 into 10 to the power minus 5 joule. So here we had the initial energy, that was 1.21 into 10 to the power minus 5 joule, and there we have the final energy on this capacitor, which is 6.05 into 10 to the power minus 5 joule. Now question is, what is the work done? So I need to find the work done in removing this dielectric. Work done in removing dielectric. You can say U final minus initial. This is 6.05 10 to the power minus 5 minus 1.21 into 10 to the power minus 5 joule. So here it is 4.8 for 10 to the power minus 5 joule. This much of work will be done in removing the dielectric. Now looking at part C of the same question, it says the same dielectric slab is now placed in B, filling the plate B completely. It means if we were having capacitor A and its capacity that we calculated was 4 into 10 to the power minus 10 farad, epsilon naught A by D, C1, and you have capacitor B whose plates whose area is just half of it, and the space here between them is filled with this dielectric of constant 9. So we will have capacity of this, it will be 9 epsilon naught A by 2 by D. So we will have the equivalent capacitance here. Question, if I just compare the two capacitance, this is 4 into 10 to the power minus 10. So I can find from here C2 as 9 by 2 epsilon naught A by D, or C2 will become 4.5 into 4, 18 into 10 to the power minus 10 farad. So we have got the two capacitance, 4 into 10 to the power minus 10 and 18 into 10 to the power minus 10. The two capacitors are then connected, and the capacitor 1 was already having a charge. It was having a charge, how much? We have already calculated 2.2 10 to the power minus 7 coulomb. And after this, they are connected to each other. They are connected to each other. Calculate the energy stored in the system. We can say, after connecting, it is QA plus QB is equal to QA dash plus QB dash, total charge. So QA is 2.2 into 10 to the power minus 7 coulomb. It is that only which will be distributed as the total charge. So if you are looking for the final energy, you can say Q square by 2C equivalent. So Q square is 2.2 10 to the power minus 7 square. 2C equivalent will be 2 into C1 plus C2. So this is 18 plus 4, 22 into 10 to the power minus 10. So the final energy we will get is 1.1 into 10 to the power minus 5 joule. This is 2.2 whole square. So it is 1.1 into 10 to the power minus 5 joule. This will be the final energy in part C of this whole combination. Now, as the last question of this level 2 of these questions on capacitor, I must say a very good level that we are doing. I would like to take this question number 27, which is also an IIT question. The question says there are the circular plates A and B of a parallel plate air capacitor have diameter 0.01 meter, 0.1 meter and are 2 into 10 to the power minus 3 meter apart. So as you can see in the diagram, there is a circular plate A and there is another circular plate B. These two circular plates have radius of them as 0.05 meter. So the radius of these two circular plates A and B is 0.05 meter, and the separation between them is 2 into 10 to the power minus 3 meter. So plate A and B have a radius 0.05 meter and they are placed 2 into 10 to the power minus 3 meter apart. There are another plates D and C. So plate D, there is another plate D here and there is another plate C here. they are having diameter slightly more, 0.12 meter, mean they will have a radius here, a 0.06 meter now, slight higher radius, 0.06 meter, and they are also 3 into 10 to the minus 3 meter apart. The gap, this gap is increased 3 into 10 to the minus 3 meter, D2. Plate A is earthen. So here plate A is having a potential 0. Plate B and D are connected to each other. So here you have seen plate B and D, they are connected to each other, and plate C is connected to a positive pole of 120 volt. So plate C is connected to battery like this and earthen, and this is 120 volt. So in a way, when they are earthen, it means like they are connected to each other. This is also at 0 volt, this is also at 0 volt, as though they are connected to each other. So this is like 120 volt is connected here across this whole combination. Calculate the combined capacitance. So let me first put the charge on them. Due to this positive, I will receive this as positive, and the inner of it will be negative. Outer of it will be positive. Outer of it will be positive. It will go towards this side. Now from here, the inner of it will be negative, the front one, and due to this negative and this positive will neutralize each other, but over here is positive, over here is negative, and the positive would go back into the earth. So it is like some Q charge will go, and Q charge will go here, and the same Q charge is coming. So if you see this arrangement, if this is capacitor C1, it's negative and it is its positive, and here it is its negative, and here it is its positive. So with the positive of this, the negative of the second is joined, they are in series. So C equivalent would be C1 C2 by C1 plus C2. And if I say how much is C1, your answer is epsilon naught into area, radius is 0.05 by D, D is 2 into 10 to the minus 3, epsilon naught A by D. If you are looking for C2, it will be epsilon naught A, area is 0.06 square by D, 3 into 10 to the minus 3. So putting this, we will get C1 C2 as 30 by 49 pi epsilon naught. So we will get equivalent capacitance. B part, find the energy stored in it. So in the B part, we are looking for the energy stored in it. If we are putting this value of epsilon naught 8.85 10 to the power minus 12 pi 22 by 7, we will get its equivalent capacitance, which is 17 picofarad. Then energy is half C equivalent into V square. So half C equivalent is 17 picofarad into V square, V is 120 square. So we will get its energy as 0.1224 microjoule. So this was another IIT question, and by doing all these 27 questions, it might have taken some time of yours, but once you do this number of questions, almost nothing is out of your reach. You are able to handle all CBSE question, all competitive question, any level competitive question.